All right, everyone, we're going to be doing the quadratic equation here for finding the discriminant and for a quadratic function. Let's find our marker again. So we'll start back from the beginning because I kind of made a little mistake there. So if we have the function of f of x is equal to ax squared plus bx plus c, and I've actually already kind of given you some hints here. So c is the vertical shift, and A is going to be the opening. So if A is less than 0, then it will open downwards, and if A is greater than 0, it will open upwards. Just giving you that for a little hint. And this is actually going to be really useful later on in this lesson, as you'll see. So for the quadratic equation, we have x is equal to negative b plus minus, color this over again, b squared minus 4ac over 2a. Now, if b squared minus 4ac always has to be equal to or greater than 0, and if b squared minus 4ac, b squared minus 4ac is less than 0, then f of x cannot equal 0 for any real number. All right, so I've decided to lay out an equation here of f of x equals negative 2x squared plus 1 plus x plus 5. Now we're just going to place that little placer 1 there because that'll help. So if we plug that in, we have negative 1 plus minus, we need a better marker here. Bear with me, please. Is this one going to work? That's much better. So negative 1 plus minus b squared minus 4ac. So we have 1 squared minus 4 times negative 2 times 5 over 2a, which simply is going to equal to negative 1 plus minus 1, so negative 4 times negative 2. Obviously, that's going to be equal to 8, and 8 times 5 is 40. So it's going to be 1 plus 40 over, that should be negative 2, 2 times negative 2, which equals to negative 1 plus minus radical 41 over negative 4. Okay, so obviously radical 41, we can't really square that, take a square root of that into any rational number. It'll just be some repeating decimal. But as we see, because 41 is greater than 0, therefore f of x equals 0 at x equals negative 1 plus radical 41 over negative 4, and at x is equal to negative 1 minus radical 41 over negative 4. If we take out the negatives, it'll just be 1 plus radical 41 over 4 and 1 minus radical 41 over 4. That makes sense. Now, if we we're going to do one for where there is no 0, and there's no 0 there because we're going to do a vertical shift and the equation opens upwards. So we'll just do f of x is equal to x squared plus 1. Or if we want to write this out to 1x squared plus 0x plus 1. So 1 is A, 0 is B, and 1 is C. So if we do negative B, that's just negative 0, which is 0, plus minus b squared, which is 0 squared, so that's just 0, minus 4 times 1 over 2a, we can see right here, which equals to 0 plus minus 4, negative 4 over 2 times 1, put that 1 right there, which equals to radical negative 4 over 2, which obviously negative 4 is less than 0, so therefore f of x does not equal 0 for any real number. There you go. Now, we're not going to do derivatives here in this one, but you can also take a derivative and just set that derivative, that tangent line. Yeah, just do the derivative and see where the tangent line passes through the x-axis, and that should be fine. We're not going to do that here, but that should help for this one. I hope you all appreciate it. And be on to our next lesson soon.